Hello, this is lesson 11-2 on the Pythagorean Theorem. In tonight's lesson, you're going to be able to use the Pythagorean Theorem, and you're also going to be able to identify right triangles. So we're going to go ahead and get started. Now, here's the idea of using the Pythagorean Theorem. All right, we can talk about a situation such as golfing, which I have right here. I have this field that you might go golfing on. And say you are starting right about here. That's your starting point. Now, I don't know a lot about golf. I'll be perfectly honest. I'm not coordinated. Yeah, just don't give me a golf club. I'm probably going to end up tossing it somewhere. All right? In fact, the one time I tried to go golfing, I wore high heels. Bad idea. All right? But I do know this. The whole goal is to get that ball from the starting point into this hole here, that little bitty hole, and as few shots as you need. That's what I know. Now, if I were to tell you this is where you have to golf, how would you shoot the ball? All right, would you shoot it over this way and then just keep going until you get there? Would you go farther around? Or some of you might say, well, I'm an avid golfer. I take a straight shot and go right that way. And looking at this, what one looks like the shortest distance? Now, to me, instead of taking this black line here, which I can trace in blue, instead of going this way, stopping, and then hitting it this way, that red line, it looks like it's the shortest distance. All right? And that's what's coming up with the Pythagorean Theorem. We're going to look at triangles, and in this particular, the right triangles. So when we talk about triangles, we're going to look at legs and hypotenuse. When we talk about the legs, those are the two shortest sides of this right triangle, and they make up a right angle. So on this one, the legs would be this line, side A and this side B, because they come together to make a right triangle. It couldn't be A and C because that's acute, as is this angle here to B to C. All right? And then the opposite side, so the opposite of that right angle, or the diagonal, is considered the hypotenuse. All right? So we're going to use those in order to do the Pythagorean Theorem. So the Pythagorean Theorem states that in any right triangle, so it has to be a right triangle, it can't be an acute triangle or an obtuse triangle, but a right one, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So say, for example, here, if this number was 2 and this number was 3, all right, we can go ahead. Actually, I want to switch that on you. We're going to go 3 and 4. All right, so if one side was 3, one was 4, they're saying this hypotenuse here, all right, if you square both of these legs, so 3 squared is 9, 4 squared is 16, and add them together, so 9 plus 16 is 25. It'll equal the square of this side, which, well, it would equal 25, but the square root of that is 5. So you can find the missing length of the side using this Pythagorean Theorem. So this is the equation they give us. A squared plus B squared. So again, the two legs are here. Those are the legs. So if you square and add together the legs, it's going to equal the square of the hypotenuse. All right, so we're going to go ahead and try this. Find the length of C. This is what they give us. And looking at it, I see that, well, C here is a diagonal. So I know I have my two legs, or the triangle has the two legs for me. So A squared, I'm going to say, is 21 centimeters squared. B squared is 28 centimeters squared. And we're left to figure out what could the hypotenuse be. So we go ahead and put this in. So 21 squared, meaning 21 times 21, is 441. And then 28 squared, so 28 times 28, is 784. And we add this together, so 784 plus 441, I get 1,225. Now, here's the thing. This gives us what C squared is equal to. So the square of C. But we don't want the square. We just want C. So what is the opposite of squaring something that we just learned in 11-1? Is that possibly square roots? And yes, it is. So what you can end up doing is square rooting both pieces. So the square root of c squared is just c, because c times c gives us c squared. And you do the same, so the square root of 1,225 is 35 centimeters. So here, c is equal to 35. Right, we get to practice a little more. So the lengths of two sides of a right triangle are given. Find the length of the third side. I want you to do A, all right, because it's very similar to the one we just did. They tell you the legs are 3 feet and 4 feet. And we're going to do B together because it's set up a little bit different. So go ahead, do A, and when you're all done, come back and check it. So pause me now. All right, so if we were to do this one, they give me the two legs, so they give me here A and B. And it doesn't matter which one you have as A and B, as the only one that really matters to make sure you get right is the diagonal, or the hypotenuse. So 3 squared plus 4 squared equals c squared. So I get 9 plus 16 is the same as c squared, which is 25. So c squared is equal to 25, but I just want c. So you square root it, and you get 5 feet is how long that other side is. Alright, so that's what you should have had for A. Let's do B together. This time, if you notice, they tell us, well, a leg is 12 meters, and the hypotenuse is 15 meters. So this time, they don't give us one of the legs. We're left to figure out what the other leg is. Alright, so this time we can't just put in 12 and 15 for A and B, because the hypotenuse, or C, is equal to 15. Okay? And then again, I'm just going to put 12 in for A, so this time we have to figure out what B is. But we start solving it the same way. We take what we know. Well, 12 squared is 144, plus B squared is equal to 15 squared, which is 225. This is what they have. Now what's different from this side to this side is before they had C squared all on its own side. Well, we need to do the same to this B squared. We have to get it by itself. So in order to do that, we need to get rid of that 144 by subtracting it. And I'm left with B squared is equal to 81. So now B's by itself, so I can square root it. So B is the same as 9 meters. So you have to be careful. Sometimes they'll give you the hypotenuse, and you need to actually get the variable by itself first before solving. All right. Now here's another thing. Sometimes you don't get just those nice, easy numbers. Sometimes you're going to get numbers with decimals. So you're just going to round it. Right? That's what they really want us to do here. Same idea, just you're rounding. Find the value of x in the triangle and round to the nearest 10. So here, taking a look, here's my right angle. So these must be the legs, and this is the hypotenuse. So I know I have to figure out what one of the legs are this time. Alright, so one leg is 7 inches squared. I don't know what the other one is, and they call it x, so I'll put an x. And then they tell me c is 14 inches squared. So doing this, well, 7 squared is 49, plus x squared is equal to, well, 14 squared is 196. All right, and then you go ahead and solve it. So here, again, I have to get x squared by itself, so I subtract 49. And I'm left with x squared is equal to 147. Well, looking at it right away, I know that's not a perfect square. So let's square root it and see what we get. All right, so 147 square root, or the square root of it is 12, and I get 0.12435 basically. But they wanted it rounded to the nearest tenth, so I'll stop at 12 and 1/10 inches. There we go. All right, and here's example 3. The carpentry terms span, rise, and rafter length are illustrated below. A carpenter wants to make a roof that has a span of 20 feet and a rise of 10 feet. What should the rafter length be? All right, and they give us this information here, which is really going to help us figure this out. So they want the whole span to be 20 feet. Okay? Then they say they want a rise of 10 feet. So you could put the 10 feet here, or it also can be put there. Now, what should the rafter length be? Meaning this piece in here. All right? Now, taking a look at this isn't going to work because this isn't a right triangle in the first place. So it's not quite what I'm looking for. But if I separate this out, look at that. This will give me the raptor length at that point. But we need to look at half the span, which in this case, if the whole span is 20 feet, half the span would be 10 feet. So we only really needed half of this roof to figure out how long each raptor length should be on both sides. So there we go. They give us 10 feet, 10 feet, and let's see. We need to figure out what the raptor length is. And looking at that, well, these are the legs. So we need to figure out what the other side would be. So again, we start with the Pythagorean theorem, a squared plus b squared equals c squared, and we put this information in. 10 feet squared is going to equal that raptor length. 10 squared is 100. So we end up with 200 is the same as c squared, but we want to solve for c, so we do the square root. So the square root of 200 is 14 and 1/10 feet. There we go. So again, when you do these, just round to the nearest tenth if you get a large decimal number. Now the second part of this lesson is talking about identifying right triangles. Because I said at the beginning, the Pythagorean theorem only works if it's a right triangle. If it's a different type, you can't use the Pythagorean theorem. So here's what we can do. Sometimes they can give us three numbers. They're going to say, this triangle has sides that are 4 and 2 and 6. And they ask, well, is that a right triangle? Well, looking at the triangle, I may obviously say no. But you can use these three numbers to determine this by doing these steps. First, you put the numbers into the equation a squared plus b squared equals c squared. So again, the two shortest numbers, or the smallest, I'm going to write smallest there. The two smallest numbers you put in for a and b. Because when we talked about legs, those are the smaller sides. The hypotenuse, or the largest number, is always used for c. All right, because that's how it works out. The hypotenuse is always the biggest one. So you're going to solve it, and then you see if both sides are equal. If both sides are equal, and it's true, it is a right triangle. But if the sides are not the same, so if it says 140 is the same as 160, it's not true, so it's not a right triangle. It would be a different type. So here's what they give us. Is a triangle with sides of 3 inches, 4 inches, and 5 inches make a right triangle? So what you do is, again, what I just said. First, put the numbers in the Pythagorean theorem. A squared plus b squared equals c squared. We're going to put the two smallest numbers in for a and b. So that is 3 and 4. And the largest number is 5 inches and goes in for c. So we solve it now. 3 squared is 9. 4 squared is 16. 5 squared is 25. 9 plus 16 is 25. And look at that. Both sides are equal, so they're the same. So this is a true statement. So yes, it is a right triangle. Now here's one they give you with this. Is a triangle with sides 10 centimeters, 24 centimeters, and 26 centimeters a right triangle? I want you to solve this one. Go ahead and solve it in the exact same manner, and when you're all done, come back and check your answer. So go ahead and pause me now. Alright, let's go ahead and check it. So a squared plus b squared is c squared. So 10 and 24 are my smallest numbers, so I put those in. So then I do the squaring. 10 squared is 100. Alright, little problems with my smartboard, but it's back now. 24 squared is 576, and 26 squared is 676. So 100 plus 576 is 676. And look at that. Both sides are in fact equal, so yes, it is a right triangle. Alright, so that's our lesson for tonight. Tonight we talked about how to use the Pythagorean theorem. So the sum of the legs, a squared plus b squared, will equal the hypotenuse squared. So a squared plus b squared equals c squared. And then we also talked about the converse of the Pythagorean theorem, or checking to see if triangles are in fact right triangles. So you have a good night. I will see you tomorrow.